The broadcast is now starting. All attendees are in listen-only mode.
Welcome everyone to this webinar by the iChemist Safety Center today. This is about understanding your lead metrics. It is all around lead process safety metrics. And my name is Dr. Zsuzsanna Gyenes, and I'm here today with Steve Fogarty, who is a principal engineer from Amok Consulting from Australia. And we will be talking about the iChemist Safety Center guidance documents, and especially Steve will talk about in details about case studies, how you can apply what is written and what is presented in the guidance document. Now, before we start the topic, I would like to kindly ask your help if you can hear me well, if you can see the slides, and everything is clear, because then you will at least you can test the question box. Somebody raises a hand, which I don't know what does it mean, so please, okay, all good. Thank you so much. Thank you for coming today. It is early in the morning in Europe, and it is late afternoon and evening in the southern hemisphere. Okay, sounds okay, works pretty good. Right. Let's jump into the details. So this is a webinar, a free webinar, and it means that after the webinar, the recording will be uploaded to the iChemist Safety Center YouTube channel, as well as to the LinkedIn. And you can rewatch the webinar and share it with your colleagues and everybody that you think would be interested in it. And more or less, the webinar will last an hour or so. During the webinar, please feel free to add your questions to the questions box. We will tackle them in the end. So the structure, how we would like to do this is we start with the general parts, and then Steve comes with the case studies, and then you will have the opportunity to ask questions. And as I always encourage people during my webinars is that please share your experience, right? Whether you are using currently the iChemist Safety Center's guidance documents, any of them, or in particular the one on lead process safety metrics, and share your experience. How is it in your operation? Whether you find it useful or you see something else that you would like to address that may be missing from the guidance document. So right. Now everybody basically says that it works pretty well. So my name is Dr. Zsuzsanna Gyenes. I'm the Deputy Director to the iChemist Safety Center. And I'm here today with Steve Fogarty, who is who's been working in operation in process safety over 25 years. And he was a really big help, and their company sponsored the iChemist Safety Center guidance document, supplementary guidance document on PRDs, and he will be talking about it later on. So first of all, if any one of you doesn't know what the iChemist Safety Center is, I would like to give you a general overview. This is our, basically this is some sort of a mission statement that we would like to bring organizations from different industry sectors, and this is something that is really important to highlight, that we want to share knowledge and what we learn in process safety. And it is also a platform, basically, where you can share your experience with each other and ask questions and share practices from your operation. Apologies for my voice. So we have operating members, industry partners, as you can see here on this slide. We work together, as you can see here, from very different industrial sectors, from absolutely different areas from the world, and also industry partners that actually support the work of the operating companies. You can see here all the the partners and the members of the iChemist Safety Center. But we also have supporting partners and collaborators that we work together with. And these are the partners from all over the world, again, different universities, process safety centers, and different authorities working from different parts of the world again. And this is really, really good because it gives a certain aspect, a certain different perspective from different parts of the world and different disciplines from the world. So it gives this unique opportunity to share the knowledge, to get the knowledge from different parts and different industries and different organizations for our work, to support our work. For more information, I will encourage you to visit our website, because there you will see all the guidance documents that are freely available for everyone. And you will see other activities that we are involved in. So in the end, you will see what I'm talking about. Where is this website? What is important about the iChemist Safety Center is that we have a so-called a framework for process safety. It is not a safety management system. It doesn't seek for replacing one, but it gives a structure how the iChemist Safety Center members want to see and want to address process safety. Why is it important that I'm mentioning this? Because as you will see later on, the lead process safety metrics actually sit exactly on this framework. So we have these elements, the 6 pillars, let's say: systems and procedures, engineering and design, assurance, knowledge and competence, human factors, and culture. And all 6 elements are underpinned by leadership. And it is crucial to mention, because leadership must be in place in every of the 6 pillars. We also run courses on these 6 pillars where I explain all the details about each element and what they actually mean, how you apply that sort of topic in your operation. So it's a really interesting concept, and it gives a frame of our work. And we also have a publication on the framework. If you are interested in, then you can download that. So why process safety lead metrics? Steve will tell you more about what is the difference between process safety, performance, and occupational health and safety metrics in the next couple of slides. Why leading? Because we have a very, very good understanding and very, very extensive literature about what lagging metrics are. So that's what we can learn from incidents, near misses, and how we can qualify them, how we can characterize them, and how to set up all these metrics. And it is really, really extensive. However, the ISC member group, actually the working group, identified that there is no consistency in how people see process safety lead metrics. So there was a need to develop some sort of consistency in this particular area. And therefore, the ISC with the member companies developed a suite of leading process safety metrics that you can apply all around in your industries. And this is the good part of it. I personally think that you can apply it in any sort of industrial sector. It's cross-disciplinary, so that you can use it for your operation, and you decide whether you need all of these lead process safety metrics in your operation, or you do a gap analysis in your system and decide whether you want to apply all of them or just part of them, or you want to add more to your operations. And there is also another interesting factor of this guidance document, is that you can add your comments. You can send your comments to us, meaning that you have discovered that you would like to add more metrics, and then you can give some feedback about those metrics that you would like to see in the guidance document. It doesn't necessarily mean that we will change it accordingly immediately or some sort of this kind of change, but we will consider and check and update the guidance document when it is necessary. And it's really important to highlight that the metrics that were developed by the members were based on daily experience in operating with those metrics. So let's try to focus on the leading part, because this is what the guidance document is about. And we try to focus on measuring the performance instead of focusing on what instead of focusing the absence of the incidents or near misses as a proxy for safety. And I don't know if you have heard about the watermelon effect, where all the metrics, all the performance indicators that you have in your operation look really green, really nice, but then deep inside they are red. So we always highlight this, that you can challenge, and you should challenge the green results to see whether they are really green or there is something that you miss. And they appear to be green, but deep inside there are some flaws in that particular metric. So that's why it's really crucial to check from time to time and understand what you measure and why you measure actually those sort of performance in your operation. Understand your numbers, understand your colors, and why is it that you are measuring them. And now I would like to give the floor to Steve, because he will explain what's the difference between occupational health and safety and process safety metrics with an example.
Thanks, Susanna. It's probably worthwhile just mentioning as well too, with that lack of a negative outcome being a proxy for a good outcome, is that CSB's done a lot of work with regards to the lead metrics side, and they've sort of agreed that lag metrics just statistically aren't significant for most organisations. So it is important that we're actually measuring the next level down to understand what's going on. So when we talk about the next level down and we talk about the difference between OH&S and process safety metrics, quite often they do measure similar things, as in they're measuring that an incident or an occurrence has occurred, someone's been injured. But the difference being that when we talk about OH&S barriers or we talk about process safety barriers, we're talking about items that prevent the type of injuries which might be related to slips, trips and falls in the OH&S space. Or in the process safety space, we might be talking about more monitoring of our process safety barriers. So the best way to describe that is to use an example. So if we're talking about a barrier that's exclusively OH&S barrier, something like working at heights would be an OH&S barrier. So although that can lead to something more significant than cuts and slips and that sort of thing, it is essentially an OH&S barrier exclusively. Then we've got some barriers which cross over into both realms. So things like permit to works and cranes. So permit to work can be there to protect OH&S type injuries with related to machinery starting or exposure to chemicals. And at the same time, permit to work can also be used for process safety side of things. So making sure that we reinstate our lock open, lock close valves at the completion of work, or making sure that we start the system up with all our maintenance overrides reinstated before we restart. So that's a good example of one that sort of straddles both. And then we do have some barriers as well, which are exclusively process safety. So something like, fire and gas or hydrocarbon piping is something that lives just in the process safety world. Okay, back to you, Susanna.
Okay, thank you. And it's really interesting because Steve mentioned permit to work, and the iChemist Safety Center is currently working on the next supplementary guidance document on permit to work systems. So hopefully we will shed some light on that particular area and help you in operation, how to measure them more effectively. And I'm pretty sure that you have seen this slide before, that it's just a really simple presentation of what is the difference between lagging metrics and leading metrics. I'm not going to spend much time on this. this is just to remind you. It's a kind reminder that that when we are talking about lagging metrics, then we talk about the measures of incidents that already occurred in the past, and they reflect on history only, and they are definitely not a predictor of future. Sometimes lagging metrics and leading metrics are not really separated, so that it's not a clear line in between the two of them, but I think it's easier to handle them separately. In terms of when you have one or the other, then you measure them, and then you can even come back and get feedback about your lagging metrics when your leading metrics don't look good. So then you just check the lagging metrics. So that is a clear indication, and the relationship between the two. And of course, leading metrics are not necessarily a predictor of future, but they help to understand what could happen and what you have to be prepared for in the future to avoid that accidents, incidents, or near misses occur in the future. So they are really important to be measured. And this is the original guidance document that we will give you a more insight of it, how it was developed, and Steve will take the floor then and tell you more about how the guidance document was put together, because he's been involved in this guidance document since the beginning, and why those metrics, and how really a challenge it was to put together all these metrics and select those metrics over many others. Of course, as I mentioned, it is free to download, and feel free to share it with anyone that you know. And this is the next one that we were involved, both of us together, and this is about lead process safety metrics, which is a supplementary guide, and especially characterized and aimed at dealing with pressure relief device design and operational performance requirements. And we just published it last year. As I mentioned earlier, currently we are developing guidance supplementary document on permit to work systems, and at the same time alarm rationalization, so that you get more detailed information about those metrics and how in particular you can measure them in your work, in your operation. So you can find other publications as well about leading and lagging metrics. So for instance, the CCPS published a lot about process safety leading and lagging metrics, as well as you can find API standard practices about process safety performance. The UK Health and Safety Executive also published how to develop your process safety indicators, and there is the IOGP document on process safety and recommended practice on key performance indicators. One publication is not here, which I always mention, is the OECD guidance document on key performance indicators. And it is actually a 2-volume document, because one is for the competent authorities and the other publication on KPIs is for operation, for industry. So that you can see here many of these publications. And back to you, Steve, to talk about how these metrics were selected.
Thanks, Susanna. So yeah, when we originally set up the first group together to actually select the metrics, it was a fairly interesting task. You saw the banner with all the operating companies early on, so there was plenty of people and plenty of history associated with what had been measured. And we actually collected over 600 different metrics that people were recording, which they believed had some relationship to process safety. So obviously that's a fairly large number, a lot of information to process. So one of the first things that we did is group those together. And in particular, we looked at what is the barrier that we're looking to check, and essentially as well, what is the level of checking or the possible benefits and issues with that particular metric. And what that identified was that some metrics, although lots of people are measuring them and they're deemed, or they've sort of got a bit of a perception of being a good metric, they can have big deficiencies or big holes. And I think a good one to mention in this space would be something like maintenance executed to plan. So we always like to see our maintenance performed according to plan, because we believe that's a good way that we can plan work and execute to the plan. But unfortunately, if you're not actually planning the right work, then it becomes a really watermelon, as soon as I mentioned earlier. So it looks green because it looks like it's doing the right job, but the reality is that safety critical maintenance that should be occurring, it's not being scheduled and it's not being executed. So some of the metrics were better than others because they had less of the undesirable outcomes and also less of the issues. So once we collaborated with those 600 odd items, the other thing we did is also had a bit of review back against the functional elements. So we talked about those functional elements being a pretty important part with the safety centre, and making sure that we don't have any of our pillars looking a bit shorter than the other ones or a little bit deficient. And surprise, surprise, full of engineers and the like working in the process safety space, and there was a couple of areas that were a little bit light on. So areas around human factors and culture were areas where there weren't a lot of metrics that were currently being recorded within the companies. Now, because we had access to the operating companies and all the people that were working within them as well, we also had access to some of the metrics that were being developed and some of the thoughts around other areas that would like to be measured. And that actually resulted in a couple of areas, or a couple of metrics that were, I guess, not well implemented with the industry, that we carried through as recommendations to use, because they were important to making sure that all our pillars had some strength to them and some robustness, and also making sure that we didn't have any blind spots or big holes. After we looked at all those metrics, we're down to about 60, and then we started to rank those based on both the value they added and also on the ease of collection. So what we didn't want to do was develop some metrics which required, a large workforce or were quite difficult to generate. So what we were able to do then is reduce that down to the 21 metrics which are in the guidance document. The other area which we also valued as being important was also consistency. So with the initial document, obviously the consistency part is important to take into consideration, but it was a little bit hard to provide in that one guidance document. And that's why the subsequent guidance document on PRVs or PSVs was released, to help try and define what that consistency looks like. And yeah, that's essentially how we took the 600 odd different process safety related metrics across the companies and distilled it down to the 21 that were published in the guideline. Okay, back to you, Susanna.
Right, so this is how the metrics, the 21 that Steve told you about, they are defined. So first of all, what you find in the guidance documents, it's really brief guidance document. You will find what is the title of the particular lead metric and what is the purpose of that particular metric, because you have to understand why is it that you are measuring that. And there is a brief description or definition about the metric. A consolidation, so that is all together with the implementation, and the linkages is really important because it shows you how it is related to other metrics that you can measure and how you can implement them in the operation. So, and there are also linkages and very brief examples as well. So that is the original guidance document, and that is what you can find. As I mentioned earlier, all the metrics sit within the framework. And this is what we have as a structure, how to build up the guidance document around these 6 pillars. And I would like to show you those 21 around these 6 pillars. So first of all, knowledge and competence. We have one metric identified by the working group, which is conformance with process safety related role competency requirement. That reminds me that the iChemist Safety Center also published a series of guidances about how you can reach different level of competency and what competencies are necessary, or we believe so that they are necessary in any operation, regardless of which industry that you represent. So that I highly encourage you to go to our website and find those free guidance documents on competency and the roadmap, how you reach actually that level of competency that you need in your role within your company. And then is the second one is under engineering and design. We have the following metrics identified. So deviations to safety critical equipment, short-term deviation, open management of change, demand on safety critical equipment, and barriers failing on demand. Meanwhile, as you can see, and I think it is not very surprising that systems and procedures have much more lead metrics identified, and you can see here those that are related to systems and procedures according to the working group. And those are the two ones that we are working as related to permit to work, and barriers fail on test, which is one of the metrics that we have investigated further in the supplementary guidance document on PRDs. Barriers fail on demand and barriers fail on test. And then assurance, where you have the number of process safety related audits to plan and number of non-conformances found in process safety audits. It's a quite...
So Susanna?
Yeah?
Yeah, I was just going to mention this obviously is a little bit shorter pill than the other ones, but the non-conformance to process safety audits, actually monitoring the number of those rather than just the execution to plan, was one of the ones that we brought forward and added in, because what we found was you actually need to understand what's going on with your process safety audit program. Quite often people are so interested in managing metrics and trying to drive numbers to 0 or to 100%, depending on which one it is, that you actually need to understand that if I've gone and I've done, you know, a reasonable level of audit, which is an annual audit, and I've come up with no actions, then something's wrong. So you need to also measure the fallibilities and the issues that you expect to find, to ensure that the level of checking and assurance is actually occurring rather than it's being done for cursory.
Yes, indeed. Thank you, Steve, for this additional information. And then we have the next pillar, which is about human factors. Obviously, when you talk about or think about human factors, all of these elements have human factor part of them, or there are aspects or elements of human factors that you should and you can consider in your work. So, but these are the most significant ones that the guidance document specifically highlights. So it's about compliance with critical procedures, critical alarms per operator hour, which is really, really interesting, and that will be also the topic of this alarm rationalization guidance document, and standing alarms as well. And culture, we have here two metrics, but Steve, I think that you also have something to add here.
Yeah, I was just going to add the process safety interactions that occur. That was another one that was sort of done with the different member companies, but done to different levels. So this is one that uses either a sort of stop work, take 5, or a behavioural-based safety, or whatever sort of program you're running. But something that actually puts a process safety component into those interactions as well. So making sure that if we go and talk about, what activities are occurring, what risks are occurring, what the business drivers are, we actually understand and can talk in a process safety culture rather than it just being something by the process safety engineers or the engineers generally. So this is also around trying to break down the, the stigmatism associated with that. But at the same time, it also allows the different trades and the operators to talk to each other as well. So we might find that the particular expertise on say, for example, on gas detection might be with the instrumentation group, but that's something that can be shared quite easily with the operations group if they start to, openly have those discussions with each other about what the particular barrier is, what the test that they're going to do is. what the risks are associated with taking that out of service and what the additional controls that they would put in place are. So yeah, that was one which I think is probably one of the ones that we've had the most positive feedback from, as in it's one that a lot of companies had as a potential blind spot.
Yeah, okay. And then I give you the floor here because now we see the case study from practice.
Okay, thanks, Susanna. So the first one I'm going to start with is just a case study on piping. So when we talked before about understanding what the barrier is, I guess this is a good way to explain the level of detail and the activities that need to occur. So purpose for piping obviously is fairly simple. It's there to keep the fluids on the inside and not the outside. But then we need to start to think about, well, how do we actually ensure that happens? So we typically have two tools in our toolkit for looking after piping. It's either an external visual inspection, or we can do thickness testing or thickness measurement with UT. So it's also important when we're doing that testing that we understand what the assumptions are, because obviously when we do testing, not everything's 100%. So the first assumption is that we can actually see 100% of the pipe to do the visual inspection. The UT can actually help us with any hidden features. That fluid composition is well understood, that the pipe's operated within the original design envelope, so things like temperature, corrosion inhibitor, biocide. And the other assumption also is that since the last inspection was done, any deficiencies have been found and corrected. So that could be coating or touch points or anything like that. Next. So as we go on to then a particular piece of piping design, which puts all that into question, is a thing called trunnions. So trunnions come in many different shapes and sizes, and there's advantages and disadvantages to all of them. This one in particular is looking at what we call pipe trunnions. So a pipe trunnion essentially is a piece of structural pipe, which is essentially exactly the same as the pressure containing pipe, but it's welded onto the pipe to provide a support. So if we have a look at the picture in the top middle, we can see that there's a piece of pipe there that's doing a bit of a zigzag, and then there's also a straight piece of pipe which is coming forward onto a beam. And the piece that's coming forward there on the beam, Susanna, is the part that's essentially structural, whereas the one that's going up and down is essentially the pressure containing pipe. Now, when we fabricate those trunnions, they're required to be welded, so there's a hole left in there for the gases to escape, and then this is where it becomes interesting. So if that hole isn't sealed up at the end of construction, what happens is that hole provides a perfectly good location for moisture to get in. Inside that pipe, there's no coating, there's no paint, so there's no protection. And for any of you that are budding horticulturists or know what an atrium is, it becomes a perfect environment for moisture condensation and corrosion. So we end up with a perfect little spot for corrosion to occur. And when we go back to that original assumptions, we talked about 100% visual. So obviously we can't see inside the trunnion, so we can't see what's going on the back of that piece of pipe. And we also are unable to UT there because we can't actually get the ultrasonic thickness tool to the back of that elbow. So alas, we are engineers, we have solutions. So X-ray is coming to the fore, and you'll see the bottom image there is actually an X-ray of a piece of pipe that's got an active trunnion in there. And what we can do with that X-ray is we can actually then measure the level of wall thickness that's been removed or the amount that's left. And you can see in that particular picture, we're down to a little bit under 2 millimeters of wall thickness left on that trunnion. So that one needed to be removed from service because it was less than the 2 millimeters required. So why I'm running through this case study as an example is when we talk about those assumptions, they are critical to understanding what holes or what potential blindsides we can have happen. And we do need to understand what those limitations and weak points are. Next. Okay, now I'm going to talk about another case study, which is essentially what led on to the supplementary guide, which is all talking about PSVs. So again, look at what the purpose is. Obviously, they're there to relieve pressure for various cases, whether or not it's blow-by or fire case or whatever the size and case may be. And we also look at what's our standard tools for inspecting and looking after. So typically with PSVs, we have an external visual inspection, which is done every 12 months. And then we have a calibration pop test, which is done every, depending on the service, 1 to 5 years for a vessel or a little bit longer for tanks. And the important part of that calibration is we need to calibrate as found, because when we talk about as found, that is actually the condition of the PSV as it was at the end of service. If we don't do the as found, then essentially that information becomes, well, essentially next to useless, because it doesn't actually tell us how the PSV is performed in service. So again, we've got some assumptions. This time we talk about the fact that we've got to have competent people who are actually doing the calibration so that they have the correct calibrated equipment and they know exactly how to do it. We also need the PSV sized correctly. So unfortunately, sometimes the PSV mightn't be actually sized for the case which it needs to relieve for. So that has to be checked and balanced. And we also have to make sure that includes things like headers and tailpipes. And the last assumption in there as well is also that we are doing the calibration at the correct interval, because obviously the previous performance on that as found calibration will define how frequently we need to do these tests. Next one. So I've got a little bit of detail here, but this is delving into the detail of the visual inspection. So if we just want to leave just the pass criteria up there for me, Susanna. So when we talk about the pass criteria, that's essentially what we get used to, which is, these are the ones that means everything's okay. So the PSV is there, it's correctly identified and tagged. There's no excessive surface corrosion and nothing's blocked or damaged. When we go down to the next part, which is the fail to danger. So even with the 12-monthly visual inspection, there can be particular things that tell us that something's gone wrong. So the first one would be something like the incorrect PSV being installed or the incorrect set pressure. So you would love to think that that can never happen, but I can say I've found it more than once or twice in my experience, and that's where the PSV's either been installed in the correct spot or there's been some confusion on the actual calibration sheet and it's been incorrectly set to a particular pressure. So that is an important thing to check and pick up on as part of the annual visual inspection. Sometimes as well, the tamper-proof seals might be damaged. So again, that's something that needs to be checked for. And then the other thing that might happen is the PSV hasn't actually made its way onto the program. So sometimes the PSV might be found, but it actually hasn't got an active program associated with it. So you might have a certification then which is out of date. There are a few more examples of things that can and has been found. From my experience as well, sensing or pilot lines being left blocked in, unfortunately, is something that can happen as well. So that's one of the critical things to check. And you would be surprised how often that can potentially occur. So it is a really important one to make sure is done properly. And again, things like incorrectly installed PSVs, sometimes they might be found as part of the initial bring on of the PSVs, and I know that was done a couple of times within my experience where the PSVs have been, particularly for remote mounted ones, they get removed as part of the campaign, they get put back up again, and then sometimes they can get put in the incorrect location. So making sure they're actually correctly installed is critical. Okay, if we go on to the next slide, Susanna, we need to talk about the actual PSV calibration side. So there's a nice picture here, which is an extract out of the guidance document. And what it tries to do is give you a visual representation of the different, between the pressure vessel operating pressures and the relieving pressures. So if we read, I guess, on the left-hand side, where it's talking about the pressure vessel, starting down the bottom. So we don't typically like to allow anything more than 90% of the operating pressure as our, the design pressure as our max operating pressure. So then 100% becomes a reference. And then we have different overpressure cases that are allowed for in the code. So we talk about the accumulation pressure at 110%. We talk about accumulation pressure for multiple PSVs, which is 116, and then we talk about the fire case, which is 21. So then if we look at the right-hand side, we then talk about what does that mean for the PSVs. So if we have a single PSV, then what that means essentially is that we run at the set pressure being 100%, which means the maximum relieving pressure should be 110. If we have multiple, then it might be staggered up to 105, and in that case, we want the maximum to relieve at 116. But in all of the cases, we want the full flow to be occurring at 121. So if we just look now at the right-hand side, what that means is depending on how many PSVs we've got installed, and for this particular bar chart here, we're talking about a single PSV, we can see that we've got what we're calling a pass, which is it falls neatly where it's supposed to fall exactly. But then we've also got failed safe, and failed safe occurs when you've got a PSV that's not operating exactly as it's supposed to, but it's still operating within its essentially design envelope. So that's what we're calling the failed safe. So although the PSV hasn't passed, it hasn't actually got to the point where it's failed to danger. And obviously the failed to danger are the ones that we are even more interested in. The failed safe we would typically look at, and that will help us to design the calibration period, but it's not something that indicates we've got an imminent, well, not imminent, that we've got a failure mode which might result in the PSV not achieving its intent. So if we have the next slide, Susanna. What we're talking about essentially here is a little bit more detail. So if we just look at the pass criteria, this is something everyone would be pretty familiar with. So this is typically what would be done as part of a technician's strip down report and calibration sheet. Again, remembering that this is done on the as found rather than the as repaired PSV. Typically what we'll find is that we'll end up with leakage rates a little bit above what the bubble rate says, and that's why the next part of the discussion is important, which is the fail-safe criteria. So if we just bring the next ones up, Susanna. What that means is if we have a PSV that doesn't meet the tightness test, but we do have, for example, a flare system or something that's scrubbing out toxic gases, then what we're saying is that although it is a fail from the exact design criteria, essentially it's a fail safe, because although it is letting a small amount of gas pass through, it will still achieve the design intent, which is not overpressuring the vessel in the event that there is an excursion. And remembering that's the purpose of what it's there to do. And the same would apply if we've got some minor blockages or build-ups with impulses and sensing lines. So as long as they still allow the valve to function as intended, then that's what we're calling the fail-safe. If we go on to the next one, Susanna, we talk about the ones that are probably of most interest and the ones that we typically need to focus the most amount of time on, which is the fail dangerous with result of calibration certification. So if we've got a PSV that hasn't lifted within 110%, then we've got concerns that it won't actually essentially relieve the vessel, which means we can then have the vessel rupture or release scenarios, which is why that one becomes particularly critical. The other thing is sometimes when the valves get stripped down, what we find is component damage or component failure. Now, that might result in the valve not being able to lift fully or not being able to lift within its 110%. So this is going to result in the possibility of either the flow rate not being achieved or the valve in another situation rather than this one actually not achieving the 110%. So it's pretty critical that the engineering side looks at that closely and understands what's gone wrong and what the failure modes are, and making sure that something's put in place to prevent those ones from occurring. The next ones talk about, I guess, some specific valves and what the different types mean. And then the last part is really around the blockages of those impulse or sensing lines. So obviously if those lines are blocked or you've got things like leaking bellows on your PSVs, then what happens is you don't actually see the real pressure that you need to at the point that's acting. And that will mean that the vessel or the item will overpressure. So that's a pretty important one to track as well. The supplementary guide has I guess essentially a lot more details on this, and it also covers off on bursting and rupture pin valves. So I encourage you, if that's an area of interest or that's something that you would like to understand further, please download the free supplement document and read away. And if there's any questions, make sure you send them through. Okay, so that's the end of the case study of essentially the equipment. What I'm going to do now is just run through a little bit of I guess, a story of my perspective of operators and how best to implement the lead metrics. So the first one required is basically to go through and look at your organisation and determine on the scope. So the scope can be the scope of the lead metrics implementation being organisational, it could be a particular part of a site. It can be as wide as you need it to be. So I guess setting that frame is important. The next part is that you use a guidance document to map what you're currently doing to the metrics in the guidance, and that will then allow you to understand what the difference is. Obviously, the gap assessment is what comes from there, and then the next part is that you use that gap assessment to determine if there are other metrics that you want to implement, or if there are other metrics that are there but similar. So I talked earlier about the maintenance performed to plan. So some metrics might already be there, but it is important that you actually have a detailed look at them and make sure that they will achieve the requirement. And the last one's pretty simple, which is just developing the action plans to address the gaps. So if we have a look at the next slide, Susanna, this is a little bit of the implementation plan on how best to do that. So first thing to do is you need to get senior leadership to understand what's going on and what the program looks like. So we talked about with the ISC framework, leadership's in the centre. If leadership doesn't understand and back up what's going on with lead metrics, you're going to be doing a serious uphill battle before you start. So there are courses and there are different ways that you can help to educate senior leadership on what the process safety lead metrics looks like. And understanding that it's not I guess a quick fix program. It generally requires a few years to implement, but setting the expectation early on is very important. So as we talked about, you've got the gap assessment and you then prioritise which ones that you believe is important and you want to get after. The next one you need to do is you actually need to understand the drivers. So you need to understand, if I start measuring this particular metric, what is possibly the drivers that are occurring? What are the positive actions that might occur? Am I set up resource-wise to help manage that? And then also, what are the potential issues? So personal experience on that one is when we started to monitor the demand on safety critical elements, what we found is that in several cases there was process control loops that weren't behaving themselves, that were causing the safety system to go off and activate in anger multiple times per day. So when you talk about process safety side of things, if we're talking about something occurring in that mode, obviously all your risk assessments and the like are completely thrown out the window. So that requires a lot of attention and an engineering resource to get after and fix, and possibly also parts and materials as well. So getting yourself forearmed and ready for these sort of things is just as important as actually measuring the metrics themselves. So if we go on to the next one, Susanna, also understanding who your actual owners or experts are, and also your change agents. So your change agents are those people that help you implement the metric. They're the ones who understand it a little bit better or have a particular interest in the area. And they're the ones that can also give you feedback and honest feedback on how the implementation's going. Nothing's better than coming back in and someone tells you that everything's perfectly well, but it's important that you understand where the pitfalls or where the potential issues might occur. Trying to not make an extra program to track it is also important. So most companies will have their HSE improvement plans anyway. Adding the requirement to track and improve on 1 or 2 metrics each year is a pretty simple thing to add in. And it also provides a lot of transparency and I guess buy-in from the wider organisation, because they've all got exposure to understand why it's being done. As far as the best way to track it, I'd suggest something similar to this. So having some sort of automated daily KPIs is really good, whether that comes from operator logs or from your data historian or some sort of information source. That's really good. It means you can include your process safety discussions in your daily management meetings. Also, having that information rolled up onto a monthly and a yearly sort of dashboard is really good. And also, obviously, making sure when your annual business planning and goal setting is occurring that you're talking about which extra metrics or which extra areas will be focused for next year is also pretty critical. Okay, the benefits. Why do we do all this? I guess the importance of actually understanding and a deep understanding of your barriers is not to be underrated. You can't do the metrics program properly without that, and that is a huge benefit into itself. So what that allows you to do is both understand where your blind spots are, where your potential issues are with your barriers. And the other thing it also does is it allows you to understand the diversity of the barriers. So when we talk about the barriers, obviously what we want to do is make sure that we have a good level of diversity. And permit to work is always one of those ones that comes up because it is the potential for lots of barriers to come undone very quickly. So if we talk about something like lock open, lock close valves, which is something that's you know, one of those important things that makes sure our safety equipment is online. Not only making sure that that's signed off, signed on and checked, but also that we go back around then and do like a 3-monthly check to make sure that all those valves are in the correct position. Those sort of things come out of understanding the barriers and the lack of diversity you've got on those barriers, because what you become exposed to very quickly is the fact that you're putting a lot of weight on those barriers, and obviously a closed valve at the back end of a PSV completely defeats all the purpose we talked about for 10 minutes on PSVs. So making sure that you understand that correctly and respect it and look after it is pretty important. Also, I guess the assumptions and limitations are important, making sure you understand those, and it will mean sometimes you have to employ extra items or extra toolkits. So we talked about things like X-rays or side scan UTs, all those sort of things. So there's new technology available and there's things that you can do when you've got a particular problem. Obviously, these aren't standard things that you would do for the entire plant, but if there's an item that you become aware of, you can use it for targeted programs. The other big benefit that you see with common lead metrics is that you are able to come up with consistent measuring. And when we talk about consistent measuring, what we're talking about is the ability to focus both resource and attention on the important things. And if it is well understood that those items are important to process safety as well, then obviously it's a good communication with the wider workforce. As I mentioned early on, potential for blind spots, so making sure that you do actually have a good coverage across the board. We talked before about the critical task by observation, so making sure that work as planned is actually work as done is one of those critical items. Making sure that you have it written down, therefore you're assuming it's happening is not good enough. Making sure that you actually confirm it's occurring by watching it occur is critical, and that prevents you from potential blind spots. The last part, I guess, is more the holy grail of what we're trying to achieve within the Safety Centre, which is to make sure that we can benchmark across companies and industries. That one's proven to be quite difficult. Everyone's very interested in furthering the process safety side, but actually getting companies to open up and share those metrics has proven to be a little bit more difficult than what was originally first thought. But at the same time, if we can achieve that, then obviously best practice can be identified and we can work out better ways to improve and do things to a higher level. And the last little comment here is Good Arts Law, which I think is a critical one when we talk about that management engagement at the start. If we just focus on the metric, then we've lost the point. The metric is not the most important thing. The most important thing is the quality of the information that goes into building it and the quality of the testing, inspection, and the integrity of the results. So you don't always want the number to be 100% or 0. You actually want the number to move. You want to understand why it's moving, absolutely, and you want to improve and investigate, but a consistent 0 and a consistent 100% basically tells you that something's gone wrong and it needs to be relooked at. Okay, so that's the end of mine. I think Susanna's just got a little bit to finish off with, and then we'll open up for questions.
Yes, thank you, Steve. And I would like to thank you for all your work and engagement and commitment to this to these two guidance documents, because you have significantly. And I would like to highlight here in the acknowledgements that we would like to thank those companies that you can see here in the list, who actively participated in building up the general guidance document as well as the PRD supplementary guidance document. So that was a great work, I believe so. And since Steve already mentioned like minimum twice the importance of the permit to work systems, I'm really excited about that one. That is the upcoming one, hopefully by the end of this year, but most probably by the first part of next year, we will be able to publish that supplementary guidance document on lead metrics. And for all of you who would like to contact us, here you can see the contact details. And as I mentioned in the beginning, this webinar recording will be uploaded to our YouTube channel, and you will see and find more information about it's always happening. So that you will see all the information also on LinkedIn if you follow us on LinkedIn. And if you have any questions, now we are opening up for the questions. Please feel free to ask them. I just try to open the question panel. Right. We have a question here, Steve. From an academic perspective, is the list of metrics considered with the rationale for each available?
Sorry, Susanna, one more time.
I think this is a question about whether the rationale for the metrics that were considered in the guidance document, the original one, whether it is available, or the rationale for each one of them.
So I guess the rationale for selecting the 21 is sort of what I've talked to, which was a combination of, I guess, both the desired outcomes, the level of coverage, and the duplication between the different metrics. Each of those metrics is quite clear on those items. So what it is it's trying to achieve, what it's trying to identify, and what the potential deficiencies or issues might be. We haven't actually published the full 600 down to 60 down to 20 risk ranking matrix, which was including the ease of capture and the effectiveness. But if that's something that was of particular interest, then I'm sure we could dig that one off someone's hard drive and make that available. So, but as far as what you need to know for the actual implementation, both from what am I trying to achieve and what are the issues, that's all well and truly clear in the guidance document.
Thank you, Steve. We have an interesting question, and I think that that needs to be clarified here, because we have a question such as why lagging process safety metrics are not significantly important. I think we and apologies if we did that, but I think we didn't mention that they are not significantly important. They are well documented and well researched and were published in other literatures. So that was the scope of the working group by the iChemist Safety Center, to focus on the lead part. And Steve, would you like to add something to that?
I was just going to say, maybe if you jump back onto that slide, Susanna, just to clarify what it's saying. It's saying that the lagging metrics are not statistically significant for most operating companies. The reason being that you do not have enough operating hours each year to track and measure, the significant events and say that that's a good measure of actual performance. So when we talk about CSBP, they've actually released this as part of the supplementary work on Montara, where they looked at, the size of organisations and how large you would need to be measuring lagging metrics as the, as the requirement for process safety. And there's definitely guidance around needing to focus on lead metrics rather than just lagging metrics. So, Susanna, I think you could just go up a couple more slides. It's on the slide that talks about slide 6. So hopefully that clarifies. So it's not saying that lagging metrics are not significant, it's just saying that they're not statistically significant for companies to use as their only measure of performance year on year. That one, yeah, that's it.
Mm-hmm.
So hopefully that clarifies the requirement. Yes, you do want to look in both the rear vision mirror and the front mirror the whole time. You don't want to not look in the rear vision mirror, but that's not the only way that you can drive. You also need to be doing the front mirror, which means you need to be doing some level of leading metrics to see how you're tracking and where you're going.
Thank you, Steve. There is a comment. At our site, the holes in the support trunnion are also treated as telltale holes. X-rays are not taken unless in shutdown or turnarounds due to the volumes involved. Okay.
Sorry, Susanna, you broke up as you were halfway through that one.
Oh, sorry. There was a comment from
Yep.
yeah, that at their side the holes in the support trunnion are also treated as telltale holes, and X-rays are not taken unless in shutdown or turnarounds due to the volumes involved.
Okay. So I guess it's like any safety program. You need to prioritise your resources and understand your risk. If that particular site is able to manage the pipework to essentially run to fail until you do have a leak of those telltales, then that would be, I guess that would be an interesting concept about how that was managed. But again, it depends on what fluids on the inside. I guess if it's something that's maybe a little bit more benign or non-flammable, then that might be able to be done. But I can tell you in our particular situation, it was a gas plant, so we were having gas releases which were of a reasonable pressure, up around 60-80 bar. So we were getting quite significant gas clouds as a result of those trunnion leaks. And for us, we were able to do the X-rays online, so we were able to do that with the plant still running. Obviously, if we found results that were less than the 2 millimetres, that resulted in that particular area of the plant required to be shut down. And the other thing that we did as well is we also looked at some of the level of corrosion products available at the telltales and also the orientation. And from that, we were also able to essentially do a bit of a risk assessment with regards to which ones to prioritise on and which ones were essentially a little bit more active than others. But yes, thank you for the comments. So hopefully that provides a little bit of clarity about what other options might be available.
Mm-hmm. Thank you, Steve. We have a question about how can we find exact practical definition of process safety incidents. I think there is quite an extensive literature available. Do you have any specific definition?
Yeah, I used to use a pretty simple example. Yeah, my pretty simple example for a process safety event rather than an incident, because you mightn't actually result in an incident, as in something mightn't actually be damaged or hurt. A process safety event is basically when one of those barriers that you've got defined is called upon to act. That means that you're in a situation where one of those items that you're relying on for your safety performance has found something that needs to be fixed or rectified. And that can be either hardware or software, or sorry, hardware or soft systems. But in the event that one of those items has been activated in anger, that will indicate that something's gone wrong. Or if any of those items doesn't perform as intended when you test it, then essentially those are process safety events. That's when your process safety barriers are being called into action, or they've failed to perform when you've tested them. I think that's a sort of simple way to define it, and that allows for the complexity or the uniqueness of each individual facility or site.
Right. Thank you. We have a very specific question here. I don't know if we can answer that now, but are those accumulations allowed in the UK as PED states 10% overpressure?
PED, I'm not 100% familiar with what that one's referring to, Susanna.
Me neither,
So
but hopefully we
can.
Yes, please contact us by email, and then we will try to find the answer. So even if we are not able to catch up on that particular question, we have. Yes.
So I was going to say it is extracted from the ASME boiler code, so I'm not sure if there is something unique to UK which would also need to be taken into consideration. But yeah, please send it through and we can have a look at it.
Mm-hmm. There is an interesting one. In addition to providing information on the 21 metrics selected, do you have commentary on those of less value? For example, in implementation as the flip of gap assessment, guidance on how to drop metrics.
Oh, okay. As in if you have too many, justifying how to get rid of some?
Yes, I guess.
Ah, yes. So there is a classic death by metrics. So we love to cover ourselves in green lights and make ourselves feel better. Rationalizing your metrics is also important, because if you have too many metrics and there's too many things you're measuring, which means there's too many things to be distracted by and also resources wasted. So your metrics might change year on year depending on what programs are being installed and what you're actually measuring and trying to keep track of. But then you've probably also got some base metrics which are always there. So I think it's important with the metrics that aren't in the guidance document that you try and map them to it and say, okay, is there anything else that we're possibly picking up on that this metric wouldn't be picking up on? And at the same time, does this metric give me a warm and fuzzy because it's green, but the reality is it's got lots of flaws or lots of possibilities that it's actually not reinforcing the right behaviour. And that's really the only way you can do a rationalisation program, where you critically look at essentially the coverage of each of those metrics and also the downcomings or the shortcomings. And that should allow you to rationalise your metrics down to something that's more manageable, or remove ones that essentially are possibly reinforcing the wrong behaviours.
Thank you, Steve. There is a question about whether we know what percentage of PSVs examined had defects or faulty installations.
Oh, okay. So is that for a plant that's been in operation, or is that a new install? I guess there's going to be a range of answers. So the requirement to set your inspection interval for your PSVs is essentially defined by the performance. And there are some guidances in the PSV codes with regards to what type of defects will allow you to extend the interval or reduce the interval. So that interval I put down as a range, something between 1 and 5 years. You typically start at 1 year, and then depending on the performance of the PSVs individually, depends on the ability to extend that out. So from my experience, I've been in situations where I might have 95% of my PSVs on a 4 or 5 year program, and I might have 5% on a 1 or 2 year program because they're not performing as well. So typically, if the PSV is not performing, it means there's a problem. It means that there's an issue with either the cleanliness of the service, so you need to look at things like barrier fluids. It might be that you're actually exposing that particular PSV to excursions that it shouldn't be seeing, which is causing it to wear out. So I guess there's no simple answer to the level of failure. Generally, the failure means something's gone wrong. If you obviously only have one failure and it's a random failure and the next time you test it, it comes good, then it might be more a fabrication or a quality of overhaul issue. So it really depends to the case-by-case basis of what the cause of the failure is, and if it's relatable to wear and tear and process conditions, or if it's more of a overhaul workmanship type problem.
Mm-hmm. We have a few more questions here. One is about that petroleum refining operation is very complex and comprises of different departments who are responsible to maintain the barriers. How do you manage department-wise and the overall? It's quite a question.
Department-wise, I guess, so part of what I talked about in the implementation plan is identifying the key stakeholders. So it's important that you establish the people that will be particularly interested in the results. And you also need to establish those change agents, or those people that will help support the program. So if you feel like there's so many departments that you're struggling to get it up and running or get it off the ground, it is also important to possibly pilot the program. So establishing somewhere where you've got good buy-in and good support, because once it's understood and once there's I guess an appreciation of what it can achieve and what it can identify, you'll bring in the stragglers just by virtue of the fact that there's a recognition of what's working. So the pilot program is always a good way to get things up and running if culturally it's a bit of a change to the organisation. But what you'll need to do then is you'll need to spend a fair bit of time within that pilot group to make sure you've got both the good news and also the honest news. So if there is really problems with how you've done something, you need to understand that and fix it early. So by the time it gets to the wider group, you know, you've got something that's a well-functioning system.
Mm-hmm. Thank you. There is a comment and a question. It seems that the leading and lagging indicator requires quite an in-depth understanding of the PRV system. It also seems that a design review is required for some of the design aspect. Can you suggest how one could operationalize this?
That's a good question. How to operationalize the requirement to perform the. So is this? I guess is that the maintenance, Susanna, or is that the actual original design? I'm not quite sure.
It's about design and a design review.
Okay. So from a design perspective, you'll notice that there are lots of different types of PSVs depending on different applications, and making sure that you've selected the right PSV and the right service is really important. If you've got a particularly nasty service, like, you know, waxy asphaltene crude oil, you need to spend a lot of time conditioning the sensing lines and the PSV so that you don't put a lot of wear and tear on it. So I think having the right level of understanding and expertise within the operational group of what you're actually trying to achieve. But if you've also got the luxury, if you've got an operating plant, then you've also got a good rich history of actual performance. And if you're in that situation where you're actually up and running, what you'll find is that that information is available to you. You just need to mine it and allocate the resources to it to be able to attack what we call those problem childs. So they're the ones that aren't meeting the performance or aren't doing as intended. And they'll be the ones that you'll need to be looking at, you know, every 12 months to see if you're making a difference and improving on it. There's no, there's no sort of silver bullet, there's no definite answer, but there is definitely experience around what extra requirements you might need for PSV installations for severe or harsh services.
We have, okay, I would like to, because we have repeated like questions here, and I would like to select those that are not, haven't been addressed yet. So there is another one about, but from a different angle, about that you said a couple of times that lagging metrics are not statistically significant, whether it's provable, such as car insurance is typically based on number of accidents or speeding fines, etc. Would you like to add something to that, Steve?
I'm not sure what that one's exactly saying, Susanna. I guess the guidance around what CSPP's published is really around the operating hours of companies. So if you look at a 12-month period, unless you've got, you know, 500 operating sites worldwide, your number of, you know, plant operating hours is going to be not to the level where you're actually expected to have an incident at one every, you know, 100, 200, 500, 1,000 years. So unless you've got a large a large company with lots of operating plants, then that's essentially where you struggle to measure your performance each year and say we've had a good year because we haven't had a fire explosion this year. I hope that goes some way to explaining why statistic significance is important for companies. But yeah, it's all around your number of operating hours in that year for your size of the company.
Thank you, Steve. And I would like to thank everybody who attended this webinar. And please feel free to send more questions if you have some that we haven't covered yet. And we will try to answer to those questions. And because we have to close the webinar now because we run out of time, but it was a really, really interesting discussion. So thank you so much for your active participation. Steve, thank you so much for presenting the case studies and the practicalities behind these lead metrics. And I will upload the webinar very, very soon. Thank you so much.
Yep, thanks everyone for listening. And as Susanna said, if there's any questions or clarifications, please send them through and we will look at them and get back to you.
Thank you. Bye-bye.
Bye-bye.